Okay, we're going to continue working with the parabola by translating it up and down and left and right. First, I'd like you to recall from the previous unit where we worked with absolute value functions that when I have a parent function, I'm going to highlight the part that I'd like you to look at right now. When I have a parent function, f of x, and I decide to add k outside that function, k just stands for a constant value. For instance, in this case, we'll be adding 2 in the first graph that we look at. When I add k outside of that parent function, I'm going to be shifting the parabola up k units. If I subtract k on the outside of that function, I'll be shifting it down k units. So what's going to be very helpful for you here is if we can identify the parent function and if we can graph that parent function fairly easily. So I am going to, I'm going to do this in gray so that it doesn't stand out too much. My parent function for this first problem is x squared. So y equals x squared. You should be able to plot this function fairly quickly. And if you cannot do that, you want to go back to the last video. You want to look at the table that we created and plot those points and practice plotting those points very quickly. As quickly as I've done here, which only takes a few seconds unless you're on the computer trying to draw this. And then it takes a little bit more time to be as perfect as possible. Okay, so there's our parent function, y equals x squared. And I'm just using y here instead of function notation, g of x. But that's okay. The first function we're going to graph is where we're adding 2 outside of that parent function. The parent function is x squared. So after I square the function, I'm going to add 2. What that does is it translates all of these points, all of the points on the entire parabola, it's going to shift them up 2. So how can we do that pretty easily without having a smart board or something, or some type of computer software where we can just shift the function up 2? You know, I don't want to just do that with my computer. I want to show you how you can do this on your graph. You're going to find key points. So here are some key points that we can shift up 2. Now, these 2 points I could shift up 2, but I'm off the grid. So I'm going to start with this point right here at -2, 4, and I'm going to shift it up 2 points. Then I'm going to go to -1, 1 and shift it up 2 points. 0, 0 will be shifted up 2 points. 1, 1 will be shifted up 2 points. 2, 4 will also be shifted up 2 points. And we will get our parabola that is called g of x equals x squared plus 2. I'm going to label it y equals x squared plus 2. Now if we choose to subtract 2, that's going to take our function and shift it down 2 units. The first one we added 2, it went up 2 units. The function we're going to look at now, x squared minus 2, is going to take our parent function again. It's going to take that parent function. So let me rewrite this. You're not going to go from any other graph other than your parent function. So the parent function is y equals x squared, and from that y equals x squared, we're going to go down 2 units. Well, on this grid, we've already graphed y equals x squared. It's the gray parabola. I'm going to find my points, my key points that I want to shift down to so that I can connect the dots. And the more points we have, the better our picture is going to be. It's just like when you were a kid and you were connecting the dots. If you were drawing a snowman and you only had 10 dots to connect, it didn't turn out to be a very round snowman. But as you learned how to count to bigger numbers, they were able to put more dots on your picture, and that's where your refrigerator picture started looking really good, when they were connect the dot pictures. So what I did was I just took each of these key points from the parabola and I shifted them down 2 units. It did not change the shape of the parabola. It simply shifted the entire parabola down 2 units. And there we have a shift. This is called a vertical translation. So these are vertical translations. Okay, so what happens when we're not adding or subtracting outside of the function, we're adding or subtracting inside of the function? Well, we're going to come down here and we're going to recall that if I subtract inside the function, that is going to cause us to go right h units. And we did this in the absolute value unit with absolute value functions. So hopefully you have this down, because we're going to continue to use this not only in Algebra 1 but in Algebra 2. And if you decide to take higher level math, this will definitely be used in higher level math as well, college algebra, and pre-calculus, and calculus. So when we subtract h inside the function, we go right h units. And if we add h inside the function, we go left h units. So here's an example of adding and subtracting inside the function and what that looks like. This is, I'm going to not keep this here, but I want to show you the difference between subtracting 1 inside the function versus subtracting 1 outside. So this would be outside the function. This is inside the function. So we're going to take our parent function, which is y equals x squared, is our parent, and we are going to shift it right 1 unit. So what we must do first is we must take the graph of y equals x squared and graph it. And you should be getting very quick at this. And again, if you are not quick at this, you'll notice how I'm plotting it. I plot 0, 0, then 1, 1, then I translate it over the axis of symmetry. Remember, this has an axis of symmetry that goes right down the middle, right there. I put a 2 in, I get a 4 out, and then what do? I translate it right over the axis of symmetry. I put a 3 in, I get a 9 out, I translate it over the axis of symmetry. This right here, I'm going to do this even lighter this time than I did it last time. This is our parent function. And remember that our parent function is decreasing until it gets to the vertex, and then it starts increasing. Now I want to take this entire function and translate it right 1 unit. So I'm going to take my key points. I'm going to translate them to the right 1 unit. This does not change the shape of the parabola. It simply translated that parabola to the right. It just gave it a nice little shift, a little nudge, as you will, and said, hey, move over to the right 1 unit. So what does adding 1 do to the function when we add that 1 inside the function? It's going to cause our function to go left 1 unit. Well, what function will go left 1 unit? It's the parent function, and I can tell that the parent function is y equals x squared because of this squared right here. So I'm going to go back to my parent function, which is my gray one, and I'm going to identify key points on that parent function, and I'm going to translate them to the left 1 unit. Again, this does not change the shape of our parabola. What it does is it just gives it a little bit of a nudge and says, hey, scoot over to the left there a little bit. And not just a little bit, but scoot over to the left exactly 1 unit. So the blue function is x plus 1 quantity squared. The red graph is y equals x minus 1 quantity squared. And of course our gray graph is y equals x squared. So I have a little bit more time. I think I can do one more graph. And I'm going to do a graph where I combine functions now, or translations. What I was just going to say was I combine translations. The first type of translation was called a vertical translation. It went up and down. The second one was called a horizontal translation because it went, that's right, you guessed it, it went left and right. I'm not sure if you can see that now. Okay, you should be able to see that now. The horizontal translation goes left and right. So we are going to combine translations where we are going to use both a vertical and a horizontal translation. So we're going to look at our function and hopefully see that we can recognize the parent function to be y equals x squared. And I can see that from this square right here outside the parentheses. What I'm doing is I'm adding 3 inside the function, which will cause it to go left 3, and I'm subtracting 1 outside the function, which will cause it to go down 1 unit. So let's graph that parent function of y equals x squared. And we are going to translate this graph left 3 and down 1. Okay, so I am going to shift this function. This somehow just appeared on your screen. I'm going to shift each point left 3 and down 1. So this point will go left 3, 1, 2, 3, and down 1. This point will go left 3, 1, 2, 3, and down 1. This point will go left 3, 1, 2, 3, and down 1. The vertex at 0, 0 goes left 3, 1, 2, 3, down 1. The point 1, 1, 1, 2, 3, down 1. 1, 2, 3, down 1. 1, 2, 3, down 1. And I'm going to connect all the purple points that belong to my translated figure. Oh boy, that was almost good. And you can see that from the original graph. Oh, yikes. So sorry. From the original graph, you can see that it went left 3 and down 1. And that's how you do a combined transformation of a horizontal and vertical translation.